So around my forecast, I have created a band around which the actual value of yt will lie 95 times out of 100, which are called 95% confidence intervals. Makes life very simple. For example, take my process. Yt is equal to 2 plus 0.5 yt minus 1 plus et. And I have told you that et is a standard normal process. So sigma square E is 1. What does it mean? It says the value of yt, the forecast for yt will be 4. The value of yt, my forecast value of yt is 4, but the actual value of yt will not be 4. The actual value of yt will be probability 4 minus 1.96, okay, into 1 upon 1 minus 0.25, because pi square is 0.25, less than or equal to yt, less than or equal to, yeah. So all these are numbers now. So it says yt will lie a little at value 4 or above 4, 95 times out of 100. So what I have created, therefore this idea is useful. This idea is not useful because I have got unbiased forecast. That's a nonsensical, that's a very trivial statement, because if I take average of something as a forecast, then I have to be correct on an average. So they'll tell you much. This is a useful one. Okay, now let me test your statistical understanding. I told you could do this because I told you that sigma square, that the error term was a normally distributed random error term. So it was standard normal, so sigma square E was 1. Suppose you do not know what is sigma square E. Exactly. Then what you will do? You will do a regression. Yt is equal to alpha plus 5 yt minus 1 plus et. Variance of et will be given by summation e hat t square upon n minus 2. That will be your estimate of sigma hat square E. Right? Now because these are estimated standard errors, it will become the t distribution. And then you will use not minus 1.96 plus 1.96, but the appropriate lower 2.5% value of the t distribution, upper 97.5% values of the t distribution. You will create confidence intervals. Right? You will create confidence intervals. Is this idea clear? Right? How does one create 95% confidence intervals? Right? If you have to create 90% confidence intervals, what will you do? You will use the lower 10% and the upper 90%, right? The lower 5% and the upper 95%. You will get 90% confidence intervals. So that's a choice that you have to make. That's a choice that you have to make. Right? That's a choice that you have to make. Okay. Now, these forecasts have a particular name. See, in a sense, what is our forecast of y? The mean of y. The unconditional mean of y. Right? We have used the unconditional expectation yt is the unconditional mean of y. That is called, therefore this forecast is called an unconditional forecast. What we got is an unconditional forecast for y, and the value of that forecast is not actually in the forecast but in the confidence intervals. Right? Okay? But the confidence intervals will stay constant for all time to come. They will not change because all these values are. What we can do is we can actually improve upon this by using what are called conditional forecasts. Okay? Using what are called conditional forecasts, and that we will see in the next class before we wind up. Right? I require one more lecture with you for about an hour or so, and another 1 hour for solving the doubts that you might have. Right? But I don't want to saturate you too much for today because we have done quite a lot. Sure? So, we will look at the conditional forecasts in the next class. When is the exam? Next week. Can we have a class on Monday?
Monday we need to ask the macro way or microwave.
Tuesday?
Saturday.
This Saturday our conference is for 2 days. Or you want to go through it right now? Are you tired or not tired? Okay. Let's take a few minutes so we can. Right? Sure. And you already have something recorded, so you can actually take a break and come back and listen to it. Right? Sure? किती वेळ आहे तुझं?
10 मिनिट.
overhead and go on top. Speed like that.
Okay, so now suppose, yeah, two, exactly 2 minutes. Are you all really tired?